Students, welcome to s.mathguru classes. Now, our main discussion partial differentiation. We consider some problems. We want to solve some problems. In the last video, we solved some problems, and these are all of this easy. This is also easy. So now we want to solve this problem. Given if u equal to 1 minus 2x plus y square whole to the power minus 1 by 2. Prove that x del u del x minus y del u del y equal to y square u cube. This our problem. We have to show this. Now first we consider this one. This is very nice solution, very easy solution. So here given u equal to 1 minus 2xy plus y square whole to the power minus 1 by 2. So here given del u del x, del u del y. This represent, we first differentiate this one with respect to x partially, next with respect to y partially. Now we differentiate this del u del x, del x 1 minus 2xy plus y square whole to the power minus 1 by 2. We get this. Again, if we have ddx of x to the power suppose minus n, then this will be minus n x to the power minus n minus 1. We get this. ddx of x to the power minus n equal to minus n x to the power minus n minus 1. When you get this result, if this x, x same, then we can get this formula. But here we get 1 minus 2xy plus y square, here we get only x. These are not same. If both are same, we can write this formula. Now we are using chain rule, this must be here, then we can write this formula. So using chain rule, we get 1 minus 2xy plus y square to the power minus 1 by 2 del 1 minus 2xy plus y square into del 1 minus 2xy plus y square del x. We get this. So this will be this same. If x same, minus n x to the power minus n minus 1. So this will be minus half. N means minus half. This same. And 1 minus 2xy plus y square whole to the power minus 1 minus half minus 1. Minus n minus 1, we write this. And this is, if we differentiate 1, then this is 0. And twice y is constant, del x is 1. And y square is constant because we differentiate partially with respect to x. This is 0. So we get this 2 also cancel and minus cancel, we get y 1 minus 2xy plus y square whole to the power minus 3 by 2. We get del u del x. Del u del x equal to this. We get this one. Now again we differentiate partially with respect to y also. Again del u del y, this is del y 1 minus 2xy plus y square whole to the power minus 1 by 2. Again we know this formula, if x same, we write this formula, but these are not same. So again we using chain rule. Without using chain rule, we can write the formula also, result also, but better to write this, then your conception will be clear. Otherwise network will be busy, no network coverage we get. So I have written this one details, del y. If we cancelling these two, ultimately this and this, we get this one. Again same formula, x to the power minus n dx minus n 2xy y square. If we differentiate this one with respect to y, this is 0, this is twice x plus twice x into 1 plus 2y, we get this. So we get this one. 2x is constant, del y 1 and del y square del y means 2y. And these two taking common and cancel with this and minus also common. We write one step more, 1 by 2, 1 minus 2xy plus y square. This is minus half minus 1. This will be minus 3 by 2. And from this minus 2 common, x minus y we get. And minus 2, this and this cancel, we get ultimately x minus y, minus minus also cancel, and 1 minus 2xy plus y square whole to the power minus 3 by 2. This is our del u del y. So we get two differentiation with respect to x or y, del u del x, del u del y. We get this value and this value, but we are taking left hand side. Now we are taking the left hand side. Our left hand side equal to x del u del x minus y del u del y. X del u del x, we know this one x into y, 1 minus 2xy plus y square whole to the power minus 3 by 2 minus y into this one del u del y means this x minus y 1 minus 2xy plus y square whole to the power minus 3 by 2. Just multiplying this, x into del u del x means this one, xy into this, and minus y into del u del y. Del u del y is this value. Now if we calculate this one, xy 1 minus 2xy plus y square whole to the power minus 3 by 2, multiplying this xy 1 minus 2xy plus y square whole to the power minus 3 by 2, y and y we get y square and 1 minus 2xy plus y square whole to the power minus 3 by 2. This one multiplying with this one multiplying with this, and y also multiplying here, y also multiplying here. Directly we get this. But these two are like terms, this will be cancelled. So we get y square and this one we get 1 minus 2xy plus y square whole to the power minus 3 by 2. We get this. But in our answer given y square, but we get y square. And here u cube given. Now from this do or die, anyhow we have to find u cube because here y square we get, but our requirement u cube. So this can be written as y square and this will be 1 minus 2xy plus y square whole to the power minus 1 by 2 whole to the power 3. If we multiplying this, we get minus 3 by 2 because we know this formula a to the power mn. We can write a to the power m to the power n also. We get m into n. By using this formula, we get this one. And this one y square, and this is nothing but our u. U means 1 minus 2xy plus y square whole to the power minus half. So this will be u and this is whole cube. We get our right hand side. This is nothing. Ultimately we get our right hand side. So what we get, x del u del x minus y del u del y equal to y square u cube. This is the proof, hence proof. This is our proof. Very nice solution, very easy. Consider another problem. If z equal to tan of y plus x plus y minus x whole to the power 3 by 2, then show that del square z del x square equal to a square del square z del y square. We have to prove this, show this. Now solution is that solution is nothing. Z equal to given tan of y plus ax plus y minus ax whole to the power 3 by 2. This one given. So first we differentiate, we right hand side consider. We differentiate partially with respect to y. Del z del y del y tan of y plus ax del y minus ax whole to the power 3 by 2. We get this. So we know this formula, the dx of tan x, this will be sec square x, and ddx of x to the power n, this is n x to the power n minus 1. We know this formula. When you get sec square x, if this x both are same, if x same, then we write sec square x. But here tan given, here given y plus x and here y, these are different. So using chain rule, y plus ax del y plus ax into del y plus ax del y, and here also using chain rule, because x same, then we write this formula, but these are not same. Again using chain rule, y minus ax whole to the power 3 by 2 del y minus ax into del y minus ax del y. Using chain rule, we get this. We write extra this one, here also extra, this cancel, ultimately we get this and this. Here also extra, cancel, this and this, we get this. So if x same, then we write sec square x. Here also x same. We assume this is x, this is x. So tan x dx, this will be sec square x. X means y plus x. And if we differentiate del y, then this is 1 and x is constant, this is ax is constant 0. And here also we get this formula, x to the power n means n x to n minus 1 if x is same. So these two are same, we assume this is n, 3 by 2 means we assume n, and this is x to the power 3 by 2 dx. Then we get 3 by 2 y minus ax to the power 3 by 2 minus 1, this formula n minus 1, and this is 1, this is 0, this one. So what we get? We get sec square y plus ax, and this is 3 by 2 y minus ax to the power 1 by 2. Taking LCM 2, 3 minus 2, then 1 by 2. We get this is del z del y. But in our result, second order derivative given. Again we differentiate partially with respect to y. Del y del z del y del y sec square y plus ax 3 by 2 del y minus ax to the power 1 by 2. We get this one, this, and this will be del square z del y square, and sec square we differentiate partially with respect to first sec square y plus ax del sec y plus ax into del sec y plus ax del y plus ax into del y plus ax by del y, this one, plus 3 by 2. Again here also using chain rule because these two are different. If both are same, we write this formula. So again using chain, actually we should write directly also, better to write directly, but for if we jumping or skip this step, then ultimately network will be busy, no network we get. So for getting network, we write details x to the power half y minus ax to the power half del y minus ax into del y minus ax del y. We get this, and this will be, we assume sec square this one x square dx. If we have dx of x to the power n x to the power n minus 1, so we assume sec means x square dx, or we can write d dx of x square, then we write twice x. d dx of x square means twice x, so we assume this is x square, this will be twice x y plus ax into d dx of sec x means sec x into 10x, we get sec y plus ax into 10 y plus ax, and if we differentiate this, we get 1 plus 0 because del y 1 and ax constant, this is 0, and here we get 3 by 2, and same formula x to the power n becomes front side, x same 1 by 2 y minus ax to the power 1 by 2 minus 1, and del y 1, and this is 0, we get this one. So this will be 2 sec square y plus ax, and this is 10 y plus ax, this is 3 by 4 y minus ax to the power minus 1 by 2, half minus 1 minus 1 by 2, we get this one. This is del square z del y square. Now I want to write the result here. So del square z by del y square, this result we get 2 times of sec square y plus ax into 10 y plus ax plus 3 by 4 y minus ax to the power minus 1 by 2. This is number 1 we consider. Number 1 we consider, just I have written this result here. So we get del square z del y square, this one we get. Next our requirement del square z del x square. So again we differentiate this one with respect to x, del z del x, del x 10 of y plus ax del x y minus ax to the power 3 by 2, and this will be using chain rule, del 10 y plus ax del y plus ax into del y plus ax del x, and here also using chain rule because these two are not same, del y minus ax to the power 3 by 2 del y minus ax into del y minus ax del x. We get this. And this is tan xx same, this will be sec square y plus ax. And y is constant because we differentiate partially with respect to x. So this is 0 and a into 1 we get. Del x of x is 1. And this is first formula, 3 by 2 becomes front side, y minus ax to the power 3 by 2 minus 1, n minus x to the power n minus 1. And this is 0, this is minus a into 1. So ultimately we get this a taking outside, a sec square y plus ax minus this one 3 by 2 a y minus ax to the power 1 by 2, because LCM is 2, 3 minus 2, 1 by 2. We get this one. Again we differentiate this one, this is our del z del x. Again we differentiate both sides with respect to x. Again del x del z del x. This is a del x sec square y plus ax 3 by 2 a del x y minus ax to the power 1 by 2. This implies del square z del x square. And again using chain rule, del sec square y plus ax del sec of y plus ax del sec of y plus ax del y plus ax into del y plus ax del x. We get this. And here minus 3 by 2a del y minus ax to the power 1 by 2 del y minus ax into del y minus ax by del x. We get this. So this is sec x means we assume this x square dx, then we get 2x. Sec square means you consider this is x square dx, then 2x, x means 2 sec x y plus ax, and ddx of sec means sec into 10, sec y plus ax, this into 10 y plus ax. ddx of sec x means sec x into 10x, and this is 0, this is a into 1, because if we differentiate y partially with respect to x, this is 0, this will be constant 0, a is constant, del is 1, minus 3 by 2a, this is first formula, x to the power n dx, this will be 1 by 2 y minus ax 1 by 2 minus 1, this is 0, this is minus a into 1, del y del x is 0, a is constant, del x 1. So finally we get this is a multiplying here, we multiplying a here. So finally we get del square z del x square, this a we get a square we get, and this one 2 sec square, this is sec square y plus ax into 10 y plus ax, this one, and this is minus, this minus is plus, a square plus 3 by 4 a square y minus ax to the power, and half minus 1, this is minus half, we get this. So from this, taking a square common, from these two terms a square common, we get 2 sec square y plus ax into 10 y plus ax, and this is a square common, 3 by 4 y minus ax whole to the power minus 1 by 2. We get this one. This will be a square, then this whole we can write this. This is nothing but our this, and this whole we can write del square z del y square. So this is del square z del x square. This is using 1, using result 1, this one. We get this. So what we get finally, del square z del x square equal to a square del square z del x square, and this is the proof, hence short. This one. The problem, if u equal to log x cube plus y cube plus z cube minus 3xyz short at del x del y del z whole square, u equal to minus 9 by x plus y plus z whole square. We have to show this. Now we start this problem. U equal to given log of x cube plus y cube plus z cube minus 3xyz. First we differentiate partially with respect to x. Del x log of x cube plus y cube plus z cube minus 3xyz. This one given. But actually you know this formula, ddx of log x equal to 1 by x. When you get 1 by x, if this x both are same. If both are same, then we write 1 by x, but these two are not same. This is and these are not same. So this must be here for writing this formula. So using chain rule, del log of x cube plus y cube plus z cube minus 3xyz del x cube y cube z cube minus 3xyz into del x cube y cube z cube minus 3xyz by del x. We get this, and these two are same. We write 1 by x formula, 1 by x cube plus y cube plus z cube minus 3xyz into del x of x cube means 3x square, y is constant 0, z is constant 0, and 3yz del x is 1. So ultimately we get 3x square minus 3yz by x cube plus y cube plus z cube minus 3xyz. We get this is del u del x. We get this one. So first del u del x we get. Next we find del u del y. Del u del y. Del y log of x cube plus y cube plus z cube minus 3xyz, and this is using chain rule, x cube plus y cube plus z cube minus 3xyz del x cube y cube z cube minus 3xyz into del x cube y cube z cube minus 3xyz del y, and these two are same. If both are same, we write 1 by x, then 1 by this we write. This is 1 by x cube y cube z cube minus 3xyz into this is 0, this is 3y square, 0 minus 3xz, 3y square minus 3xz, and this will be del u del y, this will be 3y square minus 3xz, this is x cube plus y cube plus z cube minus 3xyz. We get this one. Now what is the technique when we find del u del x? X first is 3x square and del u del y first is 3y square. Denominator is same, denominator is x cube plus y cube plus z cube minus 3xyz, here also same. But when we differentiate partially with respect to x, first is 3x square and with respect to y means 3y square. And when we differentiate partially with respect to x, here x is absent. When differentiate partially with respect to y, here y is absent. So similarly, we can write the second one, third one. Similarly, no need to find del u del z equal to first 3z square, next 3xy by x cube y cube z cube minus 3xyz. We get this one. So these are the values. Now we consider this is number 1, this is number 2, this is number 3 we get. We get 1, 2, 3. Now adding 1, 2, 3, now 1 plus 2 plus 3, this implies in 1 we get del u del x and 2 del u del y and 3 del u del z. This equal to in 1 right hand side is 3x square minus 3yz by x cube plus y cube plus z cube minus 3xyz, and this one 3y square minus 3xz by x cube plus y cube plus z cube minus 3xyz plus this one 3z square minus 3xy by x cube plus y cube plus z cube minus 3xyz. Just adding 1, 2, 3 we get this result. So from this, taking LCM, LCM is x cube plus y cube plus z cube minus 3xyz. And here we get 3x square minus 3yz, 3y square minus 3xz, 3z square minus 3xy. This is 3xy. So from numerator we taking 3 common, 3xyz, 3 common, all the terms 3 common, then we get x square minus yz, y square minus xz, z square minus xy. We get this one, and this will be, again we know this is a formula, direct formula. We know this formula from lower class: a cube plus b cube plus c cube minus 3abc. A cube plus b cube plus c cube minus 3abc equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. We write this formula: a cube plus b cube plus c cube minus 3abc equal to a plus b plus c, a square b square c square minus ab minus bc minus ca. So this is a cube b cube c cube minus 3abc. So this can be written as x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. And here we write square term together: x square y square z square, this first, next xy minus yz minus zx. We write this, and these two will be cancelled. We get this one, and from this 3 we can write in this way also: del del x del del y del z u taking common, we get this, and this after cancelling you get 3 by x plus y plus z. We get this result. But in our result, del del x del del y del del z whole square given. So we taking left hand side. Now taking left hand side. In left hand side, del del x del del y del z whole square u, we can write del x del y del z into del x del y del z u. So whole square means we write 2 times, and this, and we know this value we know this. So this will be del x del y del z, and this value into u we get 3 by x plus y plus z, and this is 3 del x 3 by x plus y plus z, del y 3 by x plus y plus z, and this is del z 3 by x plus y plus z. So all the terms are same. First we show one term. I want to show one term. First we consider this, other result will be same. So if we are taking del x 3 constant outside, then x plus y plus z whole to the power minus 1. If we taking this one in numerator, you get minus 1. 1 by this, taking 3 outside, then 1 by this. And if we using chain rule, then x plus y plus z del x plus y plus z into del x plus y plus z del x. This is minus 1. 3 into minus 1 and x plus y plus z whole to the power minus 2. This is 1, others will be 0. So we get minus 3 x plus y plus z whole to the power minus 2, or we can write minus 3 by x plus y plus z whole square we can write. So numerator is free from x, y, z, and denominator x plus y plus z whole square. So this formula, first formula, n minus 1 minus 1 minus 1, this formula ddx of x to the power n x to the power n minus 1. N means minus 1 minus 1 minus 1 minus 1 minus 2. So I have written directly, no need to show all the terms. Directly we get 3 into this we get this result. So all of these are same, then this we can write directly 3 by x plus y plus z whole square plus this will be 3 by x plus y plus z whole square plus this is also same method if we using, then we get this x plus y plus z whole square, and this is all of these are like term, this is 9 by x plus y plus z whole square, and in our left hand side del x del y del del z whole square u, this equal to this, and this is our proof. Sure, this is our result. Very nice solution, very easy, very simple also. So this is solution is long, I have written details, but we can skip the step also. So if we skip the step, then your network will be busy, no network coverage. So for getting network, I solve this problem in details. So dear students, I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.